Okay, we're going to continue our discussion about triangles and proportions, and we're going to look at specifically two theorems here. So the first one is going to be the side splitter theorem. So it's a lot like it sounds. It splits up the sides and happens to split them up proportionally. So you can see over here the proportion that's created. When you have in a triangle two parallel lines, one is the side and one is anywhere inside the triangle. This is not necessarily a mid-segment, although it could be. Then you have that XR, the length of it, is proportional to RQ, and YS is proportional to SQ. And there are different ways to set this up. You could do QR over QS is equal to RX over SY. Just follow your regular rules for the proportions in order to set them up. Okay, so we're going to actually use this now. So I notice that I've got the two parallel lines in my triangle here. One is the side of the triangle, one is in the inside. And I'm going to set up a proportion. So for example, I could do the length of MK over the length of KP is equal to the length of ML over the length of LN. And then I've got some values that I can plug in there. So I know that it's 12 over x plus 1 is equal to 9 over x. And then to solve, I need to cross multiply. So remember, when you multiply 9 times this binomial, you're multiplying times the whole thing. So you're going to end up distributing. And then 12 times x. So keep going through, follow your algebra rules, subtract the 9x, and then finally divide. So x is equal to 3. And for this problem, we're done. Remember to make sure that they're not asking you for the actual length and that it's just the variable itself. Alright, here's one for you to try. First, try to get the setup correct. Then we'll work through how to solve it. Pause the video and then unpause it when you're ready to see the answer. Okay, this is the proportion that I came up with. Remember, yours might look a little bit differently. But if you follow the rules for the proportions, they should still be equivalent. And, alright, so let's go through. We're going to cross multiply. A times A, that's A squared. And then 2 times this entire thing over here, we're going to have to distribute. Okay, now notice that it's a quadratic. So start by setting it equal to 0 and pause the video now, and then when you're ready to see if you got the right answer from the quadratic, press play. Okay, when you worked your way through it, hopefully you noticed that when you set it equal to 0 that this is a perfect square trinomial. So you should be able to factor it quickly into a plus 6 squared. Which means you have one solution for a, and that's going to be negative 6. Now, if you look at your diagram though, negative 6 might work for this length on the top right, but when it's just negative 6 for the other two, you can't have a negative length. So this is actually going to be no solution, because it's not going to work. Okay, here's a corollary. So basically what we've done is we've extended our triangle, because if you take these two lines right here and you keep going, they're going to meet somewhere up there. And so just this part right here is the side splitter theorem. But what they're saying is if you extend those lines of the triangle, basically, and you create more lines that are parallel, then you can create more proportions, because all of the sides that are split with those parallel lines are going to be proportional to each other. So, for example, in this problem we want to find x and y. This is another side splitter. And I notice the parallel lines. I notice that these are across from each other. So I'm going to set up the proportion quickly here. I'm going with the sides because y is actually not part of the side. It's on that parallel line there. So my proportion that I have is x plus 5 over 3 is equal to 8 over x. Remember, yours could look a little different, but if you're following the proportion rules, the properties of them, you should be equivalent to mine at least. Okay, cross multiply. making sure to distribute to that whole binomial. And x squared plus 5x is equal to 24. It's another quadratic. So start the same way. You gotta set it equal to 0, and then you're gonna factor. Okay, moving the 24 over, setting it equal to 0. I know that my first term is going to be an x and an x to get the x squared. I have a negative here, so there's a positive and a negative. And I need to get two numbers that will multiply to negative 24 that add up to 5. So I know that's going to be, that's going to be a positive 8 and a negative 3. So that means using my zero product property, x is equal to negative 8, x is equal to 3. So remember, check your answers. Negative 8 is not going to work for either of those two lengths, so that's not actually one of them, although it's an answer to the quadratic. But x equals 3 would work. Okay, now to get y, this is going to be a little different. So it's not going to use side splitter. And these are similar triangles because of angle, but I don't have a value over on this side, so I can't make my proportion. So instead I'm going to take a note and say, oh look, a right angle, and it's a right triangle. I also now know that the value of x over here is 3, which means that on the three sides of the triangle, I have two values. So in a right triangle, when you're missing a side, you can always use, let's see, I got ahead of myself with the x, but you can always use Pythagorean theorem. So a squared plus b squared equals c squared. This is a pretty basic Pythagorean theorem. So I remember that c is always the hypotenuse across from the right angle. So I know my 8 goes here. And as far as a and b, you can switch them up as you want because addition is commutative. So for example, I got y squared plus 3 squared. And then you just keep solving. So 9, 64, subtract 9, y squared equals 55. Take that square root. It's square root of 55. That radical won't actually reduce any further because its two factors are primes. So you're actually done. You have your x, you have your y, and we can go look at some other stuff. Okay, now the next theorem is going to be the triangle angle bisector theorem. Again, it's in the name. So in a triangle, you have an angle bisector, so in this case AD. Notice that they have the markings for the congruent angles so you can tell. And it makes the opposite sides proportional along with the sides. So see how the proportion is written over here, CD over DB. So where that bisector, angle bisector, splits not necessarily evenly, but splits the side of the triangle, is equal to CA over BA, sorry. The only segment that doesn't get included in this proportion here is going to be that angle bisector, so hopefully that helps you setting it up. Okay. So I'm looking at this problem, I'm noticing here that I've got two congruent angles, so PQ must be an angle bisector. So I can set up my proportion. So for example, PR over PS is going to be proportional to RQ over QS. And then all I have to do is fill in my numbers here. So PR is 12, PS is X, RQ is 10, and QS is 18. So before you cross multiply, if you can simplify, go for it. For example here, we know 10 and 18 both divide by 2, so now that becomes 5 and 9. It's just smaller numbers, so when you cross multiply, it's easier to divide. So 5 times x is 5x, 9 times 12. And then we divide. Okay, and we're here. 5 does not go evenly into 108, so you can leave it as the fraction. If you want to change it to the decimal, you're welcome to, but it is an extra step that you don't have to take. Alright, here's a few problems that you could just try out on your own. Pause the video now, try them, and then when you're ready to check your answers, press play. Okay, so check your answers. Hopefully they make some sense to you. The first one used that side splitter. First, second, and third, the corollary. And then the fourth was the side splitter, and then the fifth is the angle bisector. Okay, thank you for watching.